Hello, everyone. We'll be talking about the best practices on setting up a multi-cluster service mesh, aka Istio, in AWS. My name is Victor Yan, Senior Software Engineer at Socure. Socure is a fintech company that does identity verification platform, and we run everything in EKS with Istio. So why Istio? So Istio does provide a consistent configuration over coding for microservices in terms of security, traffic management, and observability. Uh, and multi-cluster Istio, what are the use cases for them? So it does connect different type of workload across a cluster AI to REST API, vice versa, and failover to disaster recovery, and provide location where routing on the service level. And what's the challenge of setting it up though? The main pain point is documentation. So this is the primary focus of this talk, to address the challenge by providing best practices and how to. So service A try to reach out service B in a single account, and we have multiple Istio primary control plane with high latency, for high availability and low latency. So 3 steps we need to get it done. Set up a common trust across a cluster and discover the service across a cluster, then just connect them. So the Istio D need to reach out to the EKS API server on the opposite cluster so that it can finish the service discovery. Once it's done, service A is able to route the traffic from service A to service B via the east-west gateway, which is NLB in AWS. So how does a service B can trust the service A's request in this case? So now is about time to set up common trust. So Istio supports a plugin CA architecture. We can plug in a new mesh CA to replace the self-signed mesh CA, and this mesh CA is actually signed by the root CA, and the private key is managed by AWS Cert Manager, and the AWS PCA issue plugin come in pretty handy to take care of the day 0 issuing the certificate and the day 2 task as well. So we have to talk about the cross-account AWS PCA here, because it's usually a common practice for managing all the PCAs in the centralized AWS account. So from the centralized PCA account, this IAM policy need to be created and attached to the RAM share, so that destination account is able to create an intermediate mesh CA from the AWS root CA. So as you can see on the top, we have the shared security account, which has a root CA and have a proper RAM share with IAM policy that attached to it, which is a subcoordinate CA most of the time. And then we can create a mesh CA in the 2 clusters within the same account, and they are able to establish mutual TLS between them. At this point, the common trust is established. Mesh CA is able to issue the certificate for the envoy. In terms of workload discovery, we definitely have to exchange the multiple remote secret for the 2 clusters, so that they be able to talk to each other. So that secret is associated with a long-lived token. So that's how it's going to work. And the traffic from the EKS pod has to reach out to the other EKS control plane via the public accessible setter range. So another couple tips on the workload connectivity is we need VPC connectivity via transit gateway. We also need east-west gateway traffic, which implemented in this case is NLB supporting SNI auto pass-through. Is a kind of mouthful, but that's different from TLS termination in north-south ingress gateway. So NACO rules has been honored on the inbound TCP port 15443 by default. So what about the developer experiences? So Backstage portal is a nice way to template out Terraform, create the EKS cluster and the CI/CD pipeline, so the developers can consume it without much coding.